Started. Good morning, everyone. So, in the last class, what we had discussed, we were discussing about orbit and orbital, right? So, till now, what we have studied what is an orbit, what is an orbital, what is difference between them. Then we studied the energy, that how they are arranged, which orbital will have lower energy and which orbital will have higher energy, right? So, last thing that we did yesterday was of Bohr's principle. And what of Bohr's principle says? It says that energy of orbital is depending upon n plus L value, right? Higher the value of n plus L, more the energy. Higher the value, more the energy. Value, more energy, right? And if n plus L is same, then we were discussing it on the basis of value of n. If n plus L is same, then higher the value of n, higher the energy. This was our last discussion about the orbitals. And on this basis, we arrange the orbital that 1s will have lower energy, then 2s, then 2p, then we have 3s, then we have 3p, then we have 4s, then 3d, and so on. So, till here we have done. This was our energy of orbitals, how to arrange them. Now, let us start with how to fill the electron. So, filling of electron in orbitals. So, we start the filling of electrons in the orbital. The first thing that we have to understand is that every electron will fill from lower energy to higher energy. So, what we are saying that anything in this world, what is the basics of energy, stability, what we can say, anything in this world want to decrease its potential energy. Everything wants to have lower energy, okay, and then it will move to higher energy. If energy is high, stability is less. So, when you start filling of electron, when you start to fill electron, let's say I have 2 electron and I have possibility of filling 2s and 2p. I have to fill 2 electrons and I have 2 choice over there. I can fill them in 2s, I can fill them in 2p. What I will prefer? I will prefer them to fill in 2s. Why? Because its energy is lower. Okay. So, whenever we start filling of electron, we will do it from lower energy to higher energy. The first orbital that I will fill will be 1s. After that, I will fill 2s, then I will fill 2p, then I will fill 3s, and so on, as per the degeneracy of orbital diagram that we had seen yesterday. So, the lower energy. Now, how many electrons I can fill? That we will decide later on. How to fill? That I will decide later on. But which orbital to fill? First, we have to start with 1s and then go on with respect to energy. So, this was the first thing that we have to understand in filling of electron. Now, the second rule, what it says, that is Pauli's exclusion principle. Filling of electron, second rule is Pauli's exclusion principle. What it says? It says that any 2 electrons can't have all 4 quantum numbers same. All 4 quantum number can't be same for any given 2 electrons. Now, what I have 4 quantum number, n, l, ml and ms. and the lowest possibility is in ms. That means it can be either plus half or it can be either minus half. That means any electron can't have this same along with all these three, right? So all of them can't be same. What does it directly mean? It means that any orbital can't have more than two electron. Any orbital can't have more than 2 electrons. Okay? That means if I look at S, how many orbitals it has? 1 orbital. So how many electron I can fill in it? 2. In any S orbital I can fill maximum 2. If I look at P, so P has how many orbitals? 3 orbitals. What were they? Px, Py, Pz. How many electrons I can fill? 2 in each, 6. Right? So in case of s orbital I can fill 2 electron. In case of p orbital I can fill 6 electron. Now if I go for d, in case of d, how many orbitals I had? I had 5 orbitals, right? What were they? dxy, dyz, dxz, dx2y2 and dz2. So how many electrons can I fill over here? In total I can fill 10 electrons. Now if I look at f orbital, we have 7 f or suborbit, we have 7 orbitals. And if I have 7 orbitals, how many electrons can I fill over here? 14 electrons. That means any s orbital, either it is 1s or 2s or 3s, any s orbital can have maximum 2 electron. If I have p, 2p or 3p or 4p, how many electrons it can be? 6 in each of them. If we have d, 3d, 4d or 5d, how many electrons can I fill? 10. And if I have f, 4f, 5f, 6f, how many electrons can I fill? 14. Okay? So now, these are the two rules. What I learnt earlier, that electrons must be filled from lower energy to high energy. This was the first rule. Then what I saw, any orbital can have maximum 2 electrons. That means any orbital can be filled by 2 electrons. That means what? S will have 2, P will have 6, D will have 10, F will have 14. Now, the last rule for the filling of electron will be Hund's rule. What it says? Electrons are filled parallelly and then anti-parallelly. Whenever you are filling an electron, you have to fill the electron parallelly in the orbital, in the same orbital I am talking. Let's say I have to fill 3 electrons in P. Now what we can do? If I start to fill the electrons in P, I can fill it like this: 1, 2, 3. Or I can also fill it like this: 1, 2, 3. Or I can also fill it like this: 1, 2, 3. Right? These are different possible cases. Now, which of them are correct? What I said, in any orbital, when the electron energy are same. Now, understand this. What I had said, that Px, Py, Pz, all have same energy. They are degenerate orbitals. So, when I am filling an electron in Px, I have 3 electrons. I filled first electron in Px. Now, second electron has two options. Either you can go to Py or you can go to Px. Right? We can either fill the electron in Px or in Py. Now, both the energy are same. But there is one thing, that if you keep one electron over here, when 2 same upcharged particles are kept nearby, they will cause repulsion. That will increase energy, and that's why I will prefer to go to Py. Okay? I have 2 options now. I can fill here only. So these 2 electrons will cause repulsion. right? Due to that repulsion, it will have higher energy, so this will be wrong, this will be wrong. These both are correct. Electrons are filled parallelly and then anti-parallelly. We can have one more option. Now look at this. Can I fill the electron like this? Now what does this show? Here all these 3 electrons are in the same spin, whatever spin that is. Maybe that is anti-clockwise, maybe that is clockwise, maybe that is plus half, maybe that is minus half, but whatever it is same, it is same. Similarly here, whatever it is same, but in this case, these 2 are in the same, but this one is the opposite one. Can we do this? No, this one is wrong. Now, we will discuss it later on. It is due to exchange energy that we have in detail in class 11. So, out of these 5 given options, 2 are correct. That means whenever energy is same, I will take one more example. Now, let's say I have to fill 4 in D. What can I do? 1, 2, 3, 4. Or what can I have? 1, 2, 3, 4. I can have n number of cases, right? So out of this one is wrong, wrong, right? Which one is correct? All of them should be parallel. Either this will be correct or this will be correct, right? If somewhere it is given like this, at this level, we will take this one also correct. Okay, for notification we fill it from left to right, that is the best case, but we have to fill parallelly and then anti-parallelly. That means once every orbital have parallel electrons or electrons with the same spin, then we will go for the opposite one. So we have in total 3 different rules over here. Rule number 1, you will start filling the electron from lower energy. That was rule 1. Then second rule was कि whenever we are going to fill electron, maximum I can fill 2 electron in any orbital. Okay, and third rule was that if orbitals are having same energy, then you will fill the electrons with parallel spin and then with the anti-parallel spin. Now, by using this, let's start with a electronic configuration. Let's say how to fill electron in Fe. How much electron we have? 26. Now I start to fill the electron. In iron, when I start to fill the electron, I have first orbital age 1s. How many electrons can I fill? Maximum 2. So I have written 1s2. Then in second orbit, I have 2s. How many electrons can we fill again? Only 2. Then we have 2p. How many maximum electrons can I fill? 6. Then I have 3s. How many electrons can I fill in s orbital? 2. Now after 3s I have 3p. Again maximum how many electrons can I fill? 6. Then I have 4s. How many can be there? 2. Right? Now if we check, we have already filled 20 electrons. After that I have 3d. Now D can have maximum of 10 electrons, but how many electrons are left with us right now? We have 6 electrons left. I will write it over here. This will be our electronic configuration. Okay, out of this one is filled, this one is filled, this one is filled. Because all the core electrons, all the inner orbitals will be filled first, then we will go to the higher one, right? So except the last one or 1 or 2 orbitals, rest all will be filled. That means at the end we will have, I am just representing the last one, this will be 4s. And how we will fill D? 1, 2, 3, 4, 5, all are parallel, right? After that, anti-parallel. So 3d6 will be like this. Here, these are 4 unpaired electrons. They are not paired, and rest all of them are paired. So we can also have number of paired and unpaired electron. How many orbitals are filled? This is completely filled, completely filled, completely filled, right? So except 3D, all of them are completely filled. Only in 3D we have 4 unpaired, rest all the electrons will be in pair. Okay, let's have one more example. I am writing it for potassium. 19. What will be the configuration? 1s2, then I will fill 2s, then 2p, then 3s, then 3p. How many electrons I have done? 2, 4, 10, 12, 18. 1 is left. 4s can have 2, maximum 2 electrons. So I have put over here is 4s1. Now if someone asks me how many unpaired electron, all of them are paired, right? Only 1 unpaired electron. Right now, let's take about another one, that is PB, a large one I will take. 82. How will you start with? 1s, 2s, 2, 2p, 6, 3s, 2, 3p, 6. After 3p, what I have? 4s, 2, 3d, 10. Then I will have 4p. Then 5s2. 5s2. After that we have 4d10. 5p6. Now let's check how many we have filled. 2, 4, 10, 12, 18, 20, 30, 36. 36 and 2, 38, 48, 54. After 5p, what will be there? 4f14. Then we will have 5d10. Okay. After that, 6 already done, no. 5p, 4f. One mistake we have done over here. After 5p6, there will be 6s2. Then will be 4f14. Then we have 5d10. Then we have 6p4. Now let's check. 2, 4, 10, 12, 18, 20, 30, 36, 38, 48, 54, 56, 56 and 14, 70, 80. We will have over here 82, 6p2. So this will be the configuration. Now if we check, so I think we have discussed till here. Energy level. 1 plus 0 you can check n plus L value. Once you will check, then we are going from lower energy to higher energy. First rule. Second, maximum orbital S, we can have 2. You can check in all of them. Any S can have maximum 2 electron. Any P can have maximum 6 electron. Any of D can have maximum 10 electron. And F can have 14 electron. So this was about the electronic configuration. We can write electronic configuration of any element just by using these 3 formulas, these 3 laws. Okay. Now there will be some exceptional behavior in this configuration. For example, if I look at chromium, so chromium, what I will do? 1s2, then 2s2, then 2p6, then 3s2, then 3p6, 4s2, then I will have 3d4. 2, 4, 10, 12, 18, 20, 24. 24 electrons have been filled, right? And what configuration I am getting? 4s2, 3d4. This was as per the normal rule. This is what we expect from the electronic configuration. This is the expected one, right? But now, what we actually get is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. This is the actual configuration that we get. Now what happens? For this, one electron from 4s is jumping to 3d. That means one electron of 4s gets some energy by anyhow and it will go to 3d. And this becomes more stable. This is the actual one. What happened over here? One electron of 3d is promoted to, one electron of 4s is promoted to 3d and it becomes 3d5. Now why it was done? What change does it make? One change is there. If you look 4s1 and 3d5, what is the maximum capacity of d? In d we can have maximum of 10 electrons, right? How many we have? 5. That means it is half filled. So what we know and what we have reason behind us, the half filled and full filled orbitals are more stable. Any orbital, if it is in the half filled form or if it is in the full filled form, then it will be more stable. Now reason behind it is the same thing that we said that we have to study in class 12, exchange and pairing energy, that we will discuss over there. So the reason behind of a half filled and full filled orbital being more stable is exchange energy and pairing energy. And due to this factor, what happened? One electron of 4s came to 3d and became half filled, it became more stable, and that's why this will be our correct electronic configuration. So now the question starts, is chromium the only element? Is chromium the only element that shows this electronic configuration? No, we can have a lot. For example, copper, what is expected? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. This is expected. This is expected from normal rules of electronic configuration. That means I am going to fill normally by electronic configuration rule, it will be there. But what we actually get? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. What happened over here? One electron jumped from 4s to d again. Now what happens? In fact, there is a very less energy gap between 3d and 4s orbital. Energy gap between 3d and 4s will be less. Why? Because both of them are of different orbit. What we expected, this is your third orbit, right? This is the fourth orbit. But third orbit energy is higher. The gap between 4s and 3d is very less. And due to this less energy, electron can easily jump from 4s to 3d. Due to that less gap of energy, electron can jump from 4s to 3d, and as 3d9 becomes 3d10 due to fulfilled orbital, 3d10 will be more stable. So as electron is jumping from 3d to 4s, What was the first reason? First reason was the energy gap is low. Due to this, a small amount of energy can make the electron jump from 3d to 4s. Now, if electron is going from 3d to 4s, do we have any profit? Yes. We get extra stability, and that stability will be more than the energy that we have given. Now, understand this thing. If we have 3d and 4s, and in one case I have 4s and 4p. Okay. So, we can make electron jump here, or sorry, just opposite I have written again. We have 4s, then 3d, then 4p, and let's say after that we have 5s. Now, we can make electron jump from here to here, or we can also make electron jump from here to here, right? Let's say I have a chance to make a fulfilled orbital. So, I will make one electron jump from here to here. Similarly, in other setup, I have a chance to make it half filled. I can make an electron jump from here to here. But in both the jump, we need some energy. Right? Now, let's say here I provided x and here I provided y. So, that is our investment. That is the energy that I provided to the electron. What we need in return? We need stability at least equal to what we have given. Now, if the stability gained will be higher than the energy that I have provided, then jump will take place. Right? If the energy given is less, if the stability gained is higher, then this jump will take place. Otherwise, there will be no jump. And as we said, the energy gap between 4s and 3d is less. There is a less amount of energy gap here. That means a little bit stability that we gain will be fair enough to make this jump happen. Right? But in this case, energy gap is larger, so we can't make that jump. Got it? So, jump will take place. Why takes place? Or why we have abnormal electronic configuration? First, we knew that half filled and full filled are more stable. In that case, what we see? We can make a large number of elements having half filled or full filled by making electron jump. But energy gap should be lower. First criteria is energy gap should be lower. How much lower? Doesn't matter. Whatever stability I gain, it should be lower than that. If stability gained is higher, then you can make the electron jump. So, generally jump will take place between 4s and 3d. So, what is the criteria for this jump of electron? We can jump an electron to make the configuration half filled or full filled if the stability gained by the element is higher than the energy required to make the jump. So, if energy gap is lower, electron can jump easily, and due to that we can have half filled full filled configuration that will cause abnormal electronic configuration. What case we have studied? Generally you will have chromium and copper. These are normal case, chromium and copper, right? After that I am just writing the normal cases: molybdenum, niobium 41 till Ag 47. All of them 41, 42, 43 technetium, 44 rhodium, all of them will have exceptional configuration. Then again I will have Au this will have exceptional configuration. So these elements have exceptional configuration, and except this, we get exceptional configuration for F block element, large elements of F block. In periodic table, if we see, the periodic table structure will be something like this. So elements placed over here in F block, these elements have exceptional configuration. We are not going to discuss with that. We are just discussing till our main periodic table group. So here we will have chromium, copper, niobium 2, Ag, and then Au. And after that, for F block elements, you will have large number of exceptional behavior. Why? Because again the energy gap, because the energy gap for the outer orbitals of these F block element is very small. The energy gap is small. For F orbitals of F block elements, energy gap is small. So even a small stability gain will make the electron jump. So there will be exceptional configuration in F block elements. So this was about the electronic configuration. Let's sum up once, then we will go to the next topic. Now what we started with? We started with a Bohr principle. Now we have what we had said last day, कि we are going to learn here कि if I have large number of vacant orbitals, I have large number of electrons, then how can I fill them? How can I fill them one by one, right? So first, what I had to decide, which orbital I have to fill first, right now. If I have, for example, I took an example of Fe. That means I had 26 electrons, I have n number of orbitals over there. Now I am going to throw electron into different orbitals. So which orbital I will throw the first electron? That for that we have to decide which orbital will have least energy, because we will always go from lower energy to higher energy, right? So for that we have a Bohr principle that said कि energy can be arranged on the basis of n plus L and n. So after we discussed कि what is the basis of energy, what is the basis of filling, that means now we have कि which orbital I have to fill first. This was our first criteria for filling of electron. Now second, if I have different orbital, I know that I have to fill this one first. Then second case is how many electrons can I fill into it? I can't fill all the electrons in the same orbital. I can't throw all the electrons or 5 or 10 electrons in any orbitals. So what I have to decide ki how many electrons can be given into each orbital, and for that we studied Pauli's exclusion principle that said each orbital can have maximum 2 electrons. So any orbital, either it is S, either it is Px, Py, Pz, Dxy, Dyz, Dxz, Dx2y2, Dz2, anything will have, any orbital will have maximum 2 electron. And on that basis, we also calculated how many electrons can be filled in one suborbit, right? In S, we can have 2. Why? Because I have only one orbital. In P, I will have 6. Why? I have 3 orbitals. In case of D, I can fill 10. Why? Because I have 5 orbitals. In case of F, I can fill how many? 14. Why? Because I have 7 orbitals. So for the second level, so the second layer, we discussed which to fill first, we discussed how many to fill, right? After that, how to fill, and for that we came to Hund's rule. What it said, कि electrons will be filled parallelly and then anti-parallelly. Because we have degenerate orbitals. We have orbitals having same energy. For example, in P, I have same energy for Px, Py and Pz. Right? And each of them I can fill two, but one at a time. Once all of them are filled, then I will go for the second one. Okay? I can't fill the first orbital 2, second one or last one 0. The electrons should be filled parallelly and then it should go anti-parallelly. What was the reason for that? The reason for that was, if we pair the electron before having parallel, then there will be more repulsion. Right? This was the case for pairing energy and exchange energy again. Now after all this, we started to fill the electron. What we did? We started with the least energy, then to higher, then to higher, then to higher. And after we have used up all the electrons, for the last one, whatever is left, we will keep it over there. Right? So we will start with the lower one. First start with the lower one, fill 2 electrons into each orbital or number of electrons in the respective suborbit. Once you have done this, till the end, whatever electron is left at the end for the last one, we will keep it over there. Now according to Hund's rule, I will draw the orbital diagram and find how many electrons are paired, how many electrons are unpaired. Okay? So this we did for Fe, we did for K, we did for plumbum, Pb. Now there was again a twist that for some element what we find, whatever rule we have defined, whatever rule we were following, we had a way to fill the electron and we had a way to get the electronic configuration. But few elements violate this rule. For example, chromium, copper, niobium, molybdenum, technetium, argentum, aurum, all of them are not fulfilling the way we were using for other element. Now what was the reason behind this? What we got? Ki half filled and full filled orbitals are more stable. That's why if there is a possibility to make the electronic configuration half filled or full filled, then we will go for jump of electron. We can jump one electron from one orbital or penultimate cell to the ultimate cell, second outermost to outermost. When? If energy gap is low and if it is making half filled and full filled. In that case, stability gained will be more than the energy provided. Right? And one more thing that we can discuss over here, can we jump only one electron? For example, if I write for Pd, palladium, 46, what should be the configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8, 2, 4, 10, 12, 18, 20, oh sorry, 3d I have stopped, 3d10, 4p6, 5s2, 4d8, 2, 4, 10, 12, 18, 20, 30, 36, 38 and 46. This is what I expect. Right? What we were discussing till now, ki we can make one electron jump. Now look for palladium. In palladium, we have 5s2, 4d8. This is expected one. What is the actual one? Actual one is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s0, 4d10. To make the outermost orbital fulfilled, 2 electrons are jumped over here. So it's not that we can jump only one electron. Okay, don't stick to that. Just if we gain more stability by making some electron jump, then we will go for that. What is the basic reason behind it? Pairing energy, exchange energy, and wherever this will take place, we will have exceptional electronic configuration. Right? Except F block, all the list I have given, that will follow the exceptional configuration. What are they? Chromium, copper, then from niobium to argentum and then gold. These are all the exceptional behavior of electronic configuration. Okay. Now, one more thing we can add it over here, that is electronic configuration for cations and anions. For cations, how can we make a cation? Cations means positively charged, right? Any element, if I am writing Z, A, element is neutral, that means what? That means number of electron is equal to number of proton. Electron proton is same. Okay, if anyone is gaining charge, if anyone is gaining positive charge, that means it has lost electron. If it is gaining negative charge, that means it has gained electron. You can't touch this proton, not in the chemical reaction. You can touch it, but for the nuclear reaction. So in the whole chemical world, all the chemical reaction will be the game for this only, electron only. This is the particle that is responsible for all the chemical reactions. Okay, proton, neutron is not going to take part. We have only to play with electrons. So if I have cation, that means electron is lost. If we have anions, that means electron is gained. So you can gain electron to have anions, you can lose electron to have cations. But now how to lose? Which orbital will lose electron? Which orbital will gain electron? Let's say it. For cations, electrons will be lost from the outermost orbital. Electrons will be lost from the outermost orbital. For example, if I have Fe, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Now what do you mean by the outermost orbital? Let's make it clear. Largest value of n. You have to add electron according to the n plus L rule first, but you have to remove electron by the largest value of n. You have to check which orbital is having largest value of n. Here this is n, this is representing L, n, L, right? So in iron, our outermost that we, according to energy that we see, that is 3D. But when but when we have to remove the electron, I have to go for largest value of n. What is the largest value of n over here? 4. Okay, so when you will remove first electron, the first electron will be removed from 4s, 1s2, 2s2, 2p6, 3s2, 3p6. Electron is not getting removed from 3D, it will be removed from 4s. So what we will have? 4s1, 3d6. Now if I remove second electron, again largest value of n is what? 4s. So electron will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, 3d6. The first two electrons of iron were removed from 4s. Why? Because value of n was largest. Now if I have to remove one more electron, I want to remove one more electron, I want to make Fe plus 3 that exists in nature. So if I have Fe plus 3, now in even cell 4s is removed, 3s, 3p, 3d all have same value of n. Now what to do? Then we will go for n plus L. Filling of electron is first n plus L, then n. But removal of electron is first n, then n plus L. So now when value of n is same for different orbitals, then electron will be removed from the orbital having larger value of n plus L. Now, if you check the value of n, what we had 3s, we had 3p, we had 3d, value of n is same for all of them, but n plus L, here it will be 3 plus 0, 3 plus 1, 3 plus 2, so it will be 5, it will be 4, it will be 3. Which one is highest? 3d. So, if I have to remove next electron, I will go from 3d, and what I will get? Fe plus 3 will be 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 5. Okay? So, whenever we have to remove one electron, we will see which one has largest value of n. And if different orbitals have same value of n, then we will check out of them which one has largest value of n plus L. Okay, let's have one more example. Now, I am taking Mn. Okay, let's take some other one. Let us take calcium. In calcium, what we have? 20. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. 2, 4, 10, 12, 18, 20. If I have to make Ca plus 1, first electron will be removed from where? It's obvious 3, 4, highest value of this. So, it will become 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Right? If I remove second electron, what it will be? 1s2, 2s2, 2p6, 3s2, 3p6, 4s0. So, the formation of cation, we are going to check the orbital having largest value of n. We will remove electron from there. If more orbitals are there, then we will check n plus L. This was for the cations. What for anions? In anions, in cations we will removing electron. In anions we are adding electron. So, in anions it's simple. For anions, we will add electron as per the rule of filling of electron. Whatever rule we were following from the beginning, because we are adding electron, we started with this class, we started with filling of electron into orbitals. We had vacant orbitals, we had electron, we started filling it one by one. So, for anion we need to add one more extra. So, that will not be different, that will be as per our rule only. Right? For example, if I have chlorine, and what is the configuration for chlorine? 1s2, 2s2, 2p6, 3s2, 3p5. This is the configuration for chlorine, 4, 10, 12, 17. I have to add one electron. Where I will go? In this, we can't. All of them are already filled. If you add one more electron into any orbital, then our Pauli rule will be violated. That means we can't have more than 2. So, we will go for 3p. Now, what I saw in 3p, I had 5, matlab 1, 2, 3, 4, 5. There is one more space left in 3p. We can fill one more electron. So, the next electron that will be filled here will be this. And with the addition of electron, what will happen? Chlorine will become Cl minus. So, Cl minus configuration will be 1s2, 2s2, 2p6, 3s2, 3p6. So, this was all about the cations and anions. So what we have understood, how to fill the electron, how to write the electronic configuration. Once you have written the electronic configuration, then we have to see, is there any chance for extra stability by jump of 1 or 2 electron if the energy gap is less. After that, we learned how to write the electronic configuration of cation, how to remove one electron from an element to make it positively charged. And then we understood about anions. So we have completed this topic of electronic configuration. Now we will in the next class we will discuss our next DPP 3 and 4. This will be the part of your homework. You can solve all those questions. We will discuss it one by one. All of them are based upon electronic configuration, how to fill the electron, or on the basis of a little bit quantum number. So we will discuss DPP 3 and 4 in the next class, and then you will have, here I will have, so this topic is completed. Our chemistry class is over for today. For next class, we will have homework, DPP 3 and 4. We will have a small break, and after that, we will go for the next subject.
ठीक है? नेक्स्ट. Good morning to all of you. For today's session, let us start. Yesterday, you people have asked a simple problem, question number 8. Again, I want to repeat that. You have a particle. First, you take x-axis. Particle is at origin. Let us extend it. They are telling you in 0 to 3 minutes, particle had moved to plus 5 meter. Positive x-axis plus 3 meter, 5 meter. So you have at 3 minutes or second, 3 seconds, it has traveled 5 meter. Recollect the problem, see from our CBC book. Many of you have asked this problem to repeat. I'm repeating it. At 3 seconds, particle had moved plus 5 meter. Plus means positive x-axis. At 3 seconds, t equal to 3 seconds, means at 0 second, particle was at origin. At 3 seconds, it is at 5 meter. Let us suppose point is A. And at t equal to 5 seconds, it is 5 meter. At 5 seconds, its position is minus 12 meter. Positive x-axis, you have plus 5. Negative x-axis, you have minus 12 meter. Means particle has reached here. This is negative x-axis. Particle has reached to 12 meter. This side, from origin, this distance, if you take, it is 12 meter. First, yesterday only I told you, to solve any problem, 3 steps you have. First step, you must understand what are being given to you. They have given you at 3 seconds, particle had reached at plus 5 meter. Plus 5 means along positive x-axis, from origin, it has traveled 5 meter. Clear to you? And at t equal to 5 seconds, particle is at minus 12 meter. Negative x-axis you go. From origin, it is at 12 meter along negative x-axis. This is first step, what they have given to you. Now, second step, find out what they are asking from you. They are asking you ratio of displacement, ratio of displacement in between. You are considering 2 times, 0 to 3 seconds and 3 to 5 seconds. The 0 to 3 seconds, it has traveled 5 meter. Distance and displacement are equal for it. And in between 3 to 5 seconds, it has traveled. Your initial position at 3 seconds is A. And final position is here, minus 12. Then just 2 seconds, 3 to 5 seconds, how much displacement it will have. If this point is B, then by factor AB you will be denoting it. What is magnitude of this displacement? From here till here 5 meter, from here till here 12 meter, total is 17 meter. Now, ratio of displacement 0 to 3 seconds, this is 5 meter, and 3 to 5 seconds, displacement is 17 meter. If you are taking the ratio, directly you are getting 5 by 17. I hope now you understood clearly. They have not asked you 0 to 3 seconds and 0 to 5 seconds. If they will ask, find the ratio of displacement in 3 seconds and 5 seconds, then situation will be different. In 0 to 3 seconds, it is 5 meter. And 0 to 5 seconds, then it will be 12 meter. Because at 0 second particle is here, and at 5 second particle will be here, this will be 12, okay? Your answer will be 0 to 3 seconds, 5, and 0 to 5, it has gone from here till here, and again it has come back to here. It will become 5 by 12 then. But in the question they had asked you, ratio of displacement from 0 to 3 seconds and 3 to 5 seconds. When you take 3 to 5 seconds, at 3 second particle is at A, at 5 second particle is at B, this displacement is 17, answer is 5 by 17. I hope you people have understood this. Now, let us go back to these problems. Classwork. You have a bus. Yesterday, I have already discussed its theory. Now, let us do the problem. A bus is traveling. Okay, no. 1 second. I am erasing it. Have you copied it? Now, come back to this problem. A bus is traveling first 1/3 distance at the speed of 10 km per hour, next 1/3 at 20 km per hour, and last 1/3 at 60 km per hour. The average speed of the bus is. Now, if it is traveling, they may ask you speed, they may ask you average velocity. If it is traveling along a straight line path, both will be equal. Now, I have told you it will be total distance covered by total time taken. Now, my average speed, this one will be equal to 1/3 distance. Suppose it has traveled from A to B. Total is S. In this S, 1/3 distance. Let us divide in 3 parts. You have 1, 2, 3. This is S by 3. It has traveled with 10 km per hour. Let us take this as V1, this as S1. Now, this as S2, this is S by 3. It is traveling with velocity 20 km per hour. And then you take this as S3, again it is S by 3. And it is traveling with velocity 60 km per hour. 60 km per hour. Clear to you? Now, total distance covered. The total distance covered is S1 plus S2 plus S3 by total time taken T1 plus T2 plus T3. Clear to you now? Now, S1 is S by 3 plus S by 3 plus S by 3 by how much time it will take to cover first S by 3? It will be S by 3 and velocity is 10 plus S by 3 velocity is 20 plus S by 3 velocity is 60. Clear? Now, this is equal to S by 3 you take out. It is 1 by 10 plus 1 by 20 plus 1 by 60. So, how much you are getting? Average speed equal to S has cancelled 3 by here 10, 20, 60, 60, 6 plus 3 plus 1. 3 into 60 by 10. This 10, 60, 6 times 18 kilometer per hour. Check again. These are simple problem. Typical problems when you will be coming at that time we will be doing. In our CBC book, it is a well-planned book. It is building your basic concepts from which you will be getting confidence. Same kinematics, again we will start from the beginning. Okay, no? But at that time, level will be very high because before that, we will be teaching you differentiation, integration, maxima, minima. Complete basic math we will be teaching you. And then, in the problem, we will be using all those techniques. At this time, simple classical mathematics, which you have studied in class 9, 10, in school level, we are using. So, check this problem. Average speed, total distance covered by total time taken. Only one clue. Time how much? Distance by velocity we have used. I hope all of you have understood clearly. Let us move to next question. A girl swims in a swimming pool of length 100 meter. So there is a swimming pool. In that swimming pool, girl is swimming. The length is 100 meter. So suppose she has started swimming from A at one side, reaching to other side at point B. So from here she started and she reached to B. She swims from one end to another end and again reaches the starting point in 2 minutes. Again she had come back here. Where she has started, again she has reached there. Time 2 minutes they have given you. They are asking you the average velocity of the swimmer. You know very well. Average velocity is net displacement by total time taken. Now, from wherever the girl started swimming, after 2 minutes, again she is reaching back. She started from A, and again she has reached back to A. So what is initial position? A. What is final position? A. The net displacement is directed line segment in between initial and final position. How much it is? 0. When net displacement is 0, then no need to solve the problem. Whatever time it may take, answer will be 0. Why? Because net displacement is 0. Verbally you can say. So here your answer will be 0. Are you understanding clearly? If average speed they ask you, no, you calculate total distance covered. If average velocity they are asking you, you should calculate net displacement. I hope you understood it clearly. Let us move to next problem. A car covers 40 kilometers in first hour and covers 30 kilometers in next 4 hours. Find its average speed. Again, average speed is total distance covered by total time taken. So you'd see 40 first hour, 30, it does not depend in how much time it is covering. Total distance covered, we want to consider 40 kilometer here, 30 kilometer here. Total, how much it is? 70 kilometer. 40 kilometer in first hour and 30 kilometer in the next 4 hours. Find its average speed. 40 plus 30, 70. Now, total time taken. This one you got beta by adding 40 to 30, 70. By total time taken. First hour and in the next 4 hours. Total time is how much? 1 hour plus 4 hours. 1 plus 4. So this is 5 hours. Answer should be 14 kilometer. 14 kilometer per hour. Let us see. 10, 20, 15. None of these. You don't have 14 at all. Okay, no? So, answer here, you'll be ticking for none of these. Actually, none of these at that place, if they would keep 14 kilometers per hour, I think that our direct answer we would be getting. Let us move now to next problem. A body is moving in a circle with constant speed 10 meters per second. Body is moving in a circular path with constant speed of, speed they have given you. Constant speed they have given you 10 meters per second. The circumference of the circle is 40 meters. From here, again come back here, this total distance is 40 meters. Find its average velocity in 4 seconds. Simple, check here. Body is moving in circular path with constant speed of 10 meters per second. In 1 second, it is traveling 10 meters. 10 meters per second means what? And that is speed, not velocity. In 1 second, it travels 10 meters. In 4 seconds, how much distance it will travel? 40 meters. Its circumference is 40 meters. It means that in 4 seconds, particle will start from here and it will cover 40 meters. From wherever it has started, again it will return back to the same point. Again, displacement is how much? 0. Initial position is point A you take, final position you take, again point A. The net displacement of the particle or the body is 0. So what will be average velocity? It will be 0. Check. Anywhere 0 is there. 0 is not there. Your answer will be none of these. Answer should be 0. I hope you are understanding it clearly. Very simple. If you want to compute average velocity, concentrate only on two things. How to compute net displacement and how to compute total time taken. If these two you are knowing, you can easily compute mean velocity or average velocity. I hope you understood. Now, I'm moving to next problem. In the previous question, find the average speed of the particle in 2 seconds. If I go back, okay, no. Now they are telling you average speed. Average speed is distance covered by time taken. Of distance covered in 2 seconds. If you take distance covered in 2 seconds, then from here if I am starting, and this total is 40 meter, then from here it will start and it will reach here. Distance covered is 20 meter. And they're asking you average speed. Average speed in that displacement you will not consider. You will consider distance covered. In 2 seconds, how much distance is it covering? It is covering 20 meter. Now, average speed is total distance covered. Total distance covered is 20 meter by time taken 2 seconds. This will become 10 meter per second. Your answer C, 10 meter per second is available here. I hope you understood. If they will ask you, okay, in 2 seconds, what will be average velocity, then you will be considering this displacement. That will be diameter. And to get diameter, you will go for circumference 2 pi r, 40. And this is 2r. 2r will be 40 by pi. Your answer will become 40 by pi by 2, 40 by 2 pi, 20 by pi. That will become your average velocity. But here they had asked you average speed. To calculate average speed, you will have to consider total distance covered in 2 seconds. I hope you understood clearly. If you understood this, I move to next question. A person is traveling in a straight line. Okay, I'm taking a straight line. First, I have taken a straight line. It moves with uniform velocity v1 for some time. So it is moving with v1. And with uniform velocity v2 for the next equal time. So suppose I'm taking this time t and v2 again with t. They are telling you equal time. If for time t it is traveling with v1, for same time t it is traveling with v2. What is given is clear to you. Now, what are they asking you? They are asking you the average velocity. Now, to find average velocity, again, we'll go for net displacement. Suppose this displacement is S1, you know, along a straight line path, distance covered and displacement both are equal. So, this one is S1 and this one you take S2. Then, average velocity will become from here S1 plus S2 by T1 plus T2. Now, S1, it is velocity into time, v1t plus S2, it is v2t divided by T1, it is t T2, it is T, V1 plus V2, T common, by 2T. Clear to you? Now, T and T cancelled, you got V1 plus V2 by 2. Check. Answer is here, V1 plus V2 by 2. For all the problems, concept involved is same. Clear? Now, let us move to next problem. A person is traveling along a straight line, moves with uniform velocity v1 for distance x, and with a uniform velocity v2 for next equal distance, and they are asking you average velocity, again a straight line path. Person is traveling along a straight line, moving with v1 for distance x. So I am taking this distance x, and for x it is moving with velocity v1. And they say you with uniform velocity v2 for next equal distance. Equal distance means again you take x, but now it is traveling with velocity v2. In previous problem, time they have given equal. Here they have given displacement equal. But basic definition of average velocity, when you consider, it is same. Now, if you take average velocity, if average velocity you are considering here, then again you will be going for net displacement by total time taken. S1 they have given you x, S2 they have given you x, T1 x by V1, T2 x by V2. This one is 2x, divide by x you take common, 1 by V1 plus 1 by V2. X cancelled, you have V equal to 2 divided by V1 V2. Here you take V1 plus V2. This is 2 V1 V2 by V1 plus V2. Copy it. See, when time was equal, then you have got V1 plus V2 by 2. When displacement equal, then same average velocity you are getting 2 V1 V2 by V1 plus V2. Tell me, followed? Check. Develop confidence for solving this type of problem. Very easy. Once you will get concept, you can solve the problem easily. So check, there it was V1 plus V2 by 2 because time taken were equal. Here displacement equal. Answer is different. There your answer was V1 plus V2 by 2. Here answer is 2 V1 V2 by V1 plus V2. I hope you understood it. I move to next question. A boy starts from Resonance Madhapur. So I will take Madhapur here at 1 p.m. 1 p.m. and reaches Kondapur. Okay, no? So, he is reaching Kondapur. Let us take Kondapur here at 1:15 p.m. And now, he has taken a break of 30 minutes. So, this time, beta, 15 minutes. And here, he has 30 minutes, he is staying there in Kondapur. And he then starts from Resonance and 30 minutes at Kondapur, and then he starts from Resonance Kukatpalli. He reaches Resonance Kukatpalli at, this is Kondapur. And then he is reaching to Resonance Kukatpalli. He reaches Resonance Kukatpalli at 2:45. So from here, it is 1:45, and he is reaching here at 2:45 p.m. Find his average speed if distance between Madhapur to Kondapur and from Kondapur to Kukatpalli is 5 kilometer and 10 kilometer. So this one is 5 kilometer and this one is, they are giving you 10 kilometer. Again, same concept is there. They are asking you, find his average speed. I have told you that in this kind of problem, children will be concentrating on distance and displacement for this type of problem. They are a bit neglecting time taken. Yesterday, I have taken one example, not from the book. I have created my own and I have told you that if a person is standing, that time also must be considered. Here, first take total distance, how much he is covering. So from Resonance Madhapur to Kondapur, okay, he is traveling 5 kilometers. And from Kondapur to Kukatpalli, he is traveling for 10 kilometers. The total distance, how much he is covering? First, average speed. They are asking you that. It is total distance covered, S1 plus S2 by total time taken. Take here that you have T1, he had moved from Madhapur to Kondapur, and then T2, the time for which he was staying in Kondapur, T2 plus. Now, from Kondapur to Kukatpalli he had moved. For that he has taken time T3. And check the answer. Answer is in minute. The time you will be taking in minute only. This answer is in kilometer per minute. So distance you considered in kilometer and time you should take in minute. Now, S1, 5 kilometer. S2, it is 10 kilometer by T1, it is 15 minutes. Then T2, the time which he has passed, he was just staying there. This one is your 30 minutes. And then he has taken to move at 1:45 and he reached there at 2:45. The 2:45, 1:45 to 2:45, he has taken 60 minutes. Am I right? Or directly you can take, it is 60 plus 30 plus 15, 105 minutes. If you take from here, total time taken, basically he started at 1 o'clock and he reached there at 2:45. 1 hour, 45 minutes. In minute you tell. In 1 hour, 60 minutes plus 45 minutes. 105 minutes. Separately you take from basic definition, then T1 is 15, T2 is 30, T3 is 60. So your average speed equal to 15 kilometer by 105 minute. 15 7 ja. you are getting 1 by 7 kilometer per minute. Check the answer. Directly here, A itself is 1 by 7. Your answer is 1 by 7. In this problem, important thing is the time for which man is standing, that time also we'll have to consider. If in the process of journey, somewhere man is waiting, standing, talking, that time also must be considered to compute average speed or average velocity. In both, we'll have to consider. I hope, yesterday someone had asked classwork, so I have completed. Now, next, let us go for homework. The velocity of an object can be changed by. You want to change velocity. Velocity is what? Displacement by time, right? So either you change displacement or you change time. So when you say changing the speed, when you are changing the speed, guaranteed magnitude of speed is nothing but magnitude of velocity numerically. Speed and velocity both are not same, but in one way you can say magnitude of velocity is nothing but speed. So velocity of an object can be changed by, let us say all, changing the speed, changing the direction of motion, changing the speed and direction of motion. All are true. When you are changing speed, velocity is changed. When you are changing the direction, velocity is changed, because for velocity, change of magnitude either or change of direction or both, all are feasible. Your answer, you can say that changing both the speed and direction of motion. I think that here all answers are right. All A, B and C are true. Theoretical question. Move to next. If a car travels 500 meters in 5 minutes, find its speed in meter per second and kilometer per hour. It is just change of the unit. Okay, no. First you take car is traveling, speed, you are taking 500 meter, by time is 5 minutes. Okay, no. So meter per second. If you take this meter per second, already numerator is in meter. Only I'll have to change minute. Of 5 into 60, it is second. Minute has converted into second. How much you got? 500 by 300 meter per second. 2 zeros cancelled. It is 5 by 3. Okay, no. This speed will be 5 by 3 meter per second. And I am not finding that any answer. And kilometer per hour, if you want to convert, then same 500 meter is 0.5 kilometer. Understanding now? 1000 meter is 1 kilometer. In my childhood, I was mugging up. Millicenti, decigram, deca, hectokilogram, all multiple 10. In class 2 or 3, my Guruji in my village has taught me this. Milli, centi, decigram, deca, hecto, kilogram. Everywhere multiple is 10. You are converting 500 meter into kilometer. How much kilometer 500 meter will be? Half kilometer. Half kilometer means 0.5 kilometer, and I want to convert 5 minutes into hour. 60 minutes, 1 hour. So this will become 5 by 60. Now it is hour. Unit become kilometer per hour. Now 60 will go up. 0.5 into 60 by 5 kilometer per hour. 0.50 cancel. 5 cancel. How much you got? 6 kilometer per hour. Are you understanding now? Please check. 6 kilometer per hour is there. Okay, no. But here they had given you 2. I am getting here 5 by 3. Right now. So, none of these will be taking, because both together they are asking you, na? Only one is correct. Kilometer per hour is correct, but speed in meter per second is not correct. So I'll be opting for none of these. Let us move to next. A boy running at an average speed of 4 kilometers per hour reaches the school from his home in half an hour. The distance of the school from his home is. Suppose this is his home, and a straight line path here, it is his school. Right? His average speed, they have given you 4 kilometers per hour. This will be equal to, this is the speed. This will be equal to distance covered by time taken. They have told you child is reaching to school from his home in half an hour. The half an hour to 1 by 2 hour. Okay, no? So what will be S? S will be equal to 4 kilometers per hour into half hour. Hour cancel 2. You are getting 2 kilometers. Answer is A. Tell me, have you followed it? Did you understand? Clearly, direct definition we are using. Now, we'll go to next question. A body moves from A to F. Check where it is. He is going from A to B to C to O to D to E to F. He is going like this, beta. In this way he is going. Along the path shown below in 10 seconds. Total time taken is 10 seconds. They are asking you distance and displacement. Right now, if you take distance covered, simply 10 seconds is not utilized at all now. Only you'll have to compute distance and displacement. Distance covered is total length of the path. The total length of the path 5 meters plus 10 meters plus 5 meters plus 5 meters plus 10 meters plus 5 meters. You have already gone from A to B, B to C, C to O, O to D, D to E, and E to F. Now add 15, 20, 25, 35, 40. So your distance covered is 40. They have not given you. They are asking you first distance and displacement. So first term will be, okay, distance covered. Your distance covered is again 5, 15, 20, 25, 35, 40. So distance covered will be equal to 40 meter. Understanding now? And if you consider displacement, displacement is directed line segment, means a straight line, length of a straight line in between initial position and final position. Now its initial position is A, it is here, and final position is F, it is here. It does not depend upon at all on whatever path particle had moved. Whatever path particle is choosing to move from initial to final position, on that distance depends. Displacement does not depend at all upon the path. It only depends upon initial and final position. Your initial position is A, final position is F. So this length will be giving you the magnitude of displacement. This length if you take, so if this is 10 meter, this is 10 meter, this is 10 meter, this is 10 meter. So your displacement, this will be equal to 20 meter. 40 meter and 20 meter, where is the answer? Not a single answer it is. Answer will be 40 meter distance covered and 20 meter will be displacement. Answer should be 40-20. Not a single answer is 40-20. Here they have given 20 and 40. This answer will be, if they will ask me, the displacement and distance will be. Tell me. Followed clearly? No doubt now? Evening you will get doubt. Again you ask me in the evening. Okay, no. I want that my children should be perfect in solving the problem. Not only math is tool for understanding physics. Okay, no. I want nowadays better. Concept is very important. I also say concept is very, very important. But along with concept, application nowadays becomes more important in all competitive exams. Mostly application part they are asking. Problems they are asking. I want that you should practice more and more number of problems you should do. And for that purpose, our material will be the best material. Okay, no? Experience for 24, 25 years. So many changes. Latest material you will be getting when you will be coming here. And I hope all of you have our CBC book now. If you don't have, nearby, whichever campus you are finding of resonance, you go and take it. I'm solving from our CBC book only. So nicely check fundamental concepts are being cleared for you. When you'll be coming in January, June, okay, no, in the beginning, we'll not be teaching you so much basic fundamentals. We'll be teaching you. But these fundamentals now only we are clearing. Tell me. Clear? I'm moving now to next question. The displacement time graph for particle A and B are a straight line inclined at an angle of 30 degree and 60 degree with time axis. I will teach you graph separately. We have many graphs in kinematics. Displacement time graph, velocity time graph, acceleration time graph, that will be force time graph. Most important will be velocity time graph for solving the problem. I consider here, let's say, displacement time graph. If I take any quantity B which is a function of A. Means B depends upon A. If A is independent physical quantity, mostly independent physical quantity we take on x-axis. This is x-axis. On this you take independent physical quantity. And you know, time does not depend upon any quantity in Newtonian mechanics. So mostly we take time on x-axis. In any problem, if time they are taking on y-axis, be alert. Mainly for intermediate, okay, no. In theory of relativity, it is possible. A special theory of relativity, time may depend. But here in Newtonian mechanics, whatever we are learning, in that time will be completely independent. So we take time on x-axis and displacement on y-axis. Displacement depends upon time. Now what they say, you see, there are two particles A and B. And graph for these two are a straight line. They are inclined at 30 degree. First it is A, it is inclined at 30 degree. So for A, this angle is 30 degree, and for B, it is B, this is inclined at 60 degree. The ratio of velocities VA and VB, they are asking you VA and VB. Let me recollect. Go back to 9th or 10th class. You take a simple right angle triangle. I have taken a right angle triangle. This is base, this is perpendicular, this is hypotenuse, this angle is theta. Right now, you have studied. Tan theta is perpendicular by base. Perpendicular by base. Am I right now? Now, we want velocity. Velocity is displacement by time. Am I right? Displacement is on y-axis, time is on x-axis. Am I right? So, my velocity, if I drop anywhere a perpendicular, it will become a right angle triangle. So, displacement by time, if this is displacement by time, that will become tan 30 degree. But this tan 30 degree is called slope. So, velocity will be given by tan 30 degree for your particle A. Check again. Tan theta is perpendicular by base. If I take this right angle triangle, then S by T will be tan 30, and if I take this right angle triangle, then tan 60 will be S by T. Are you following now? So VA S by T, that will be tan 30 degree, and VB S by T will become tan 60 degree. Tell me, are you understanding? Now, tan 30 is 1 by root 3, tan 60 is root 3, your answer is 1 by 3. Check, your answer is here 1 by 3. Following now? Clearly? If you understood this, I move to next question. A car travels first half of a distance between two places. The first, I will take two places. So this is place A and this is place B. Car is traveling first half of the distance, first half. If I will take distance between A and B as S half, S by 2, at a speed of 30 kilometer per hour. So this is 30 kilometer per hour. It has traveled S by 2. And then the second half of the distance at 50 kilometer per hour. So this one is 50 kilometer per hour. The average speed of the car for the whole journey is so many problems on every concept you'll be finding in our book. Not only CBC book, it is just the beginner. When you'll be getting our material, in that plenty of problems for every concept it will be there. When you'll be solving those problems, your every concept will become clear. Okay, no? And if you will not be capable to do, we will always be there to help you. Okay, no? In our study hours, we'll be going on solving whatever doubt you will have. And now, see, only on speed and velocity you are getting so many problems in CBC book. Think about our real book, worksheet or DPP, how many problems you will be getting. And now, here you see, this is S by 2. Next, S by 2, 50 kilometer per hour. I think it will be damn easy for you. They're asking you average speed. This will be S1 plus S2 by T1 plus T2. S1 plus S2, S by 2 plus S by 2 by T1. So you will have S by 2 by 30 plus S by 2 by 50. I hope. Now you can do now. Calculation part simple. This is S. Here you take S by 2. Here you take 1 by 30. Here you take 1 by 50. Clear to you? Now, S cancelled. You are taking average speed. 2 up, 1 by 30 plus 1 by 50. 2 divided by here, it is 150, 5 times 50, 3 times. You are getting, this will be equal to 2 into 150 by 8, 2 4 times. Again, 2 times 75, 75 by 2, 37.5 kilometer per hour. Check every step. I hope today for any question, any child will not have any doubt. Okay? I am explaining you every problem in too much detail. But still, if you have doubt, you can ask. Because all children will not be having same IQ. Okay, no, we are always there. Tell me, understood this? I move to next question. A 150 long train, 150 meter. There is a train, length is 150 meter. So I am taking first train, it is 150 meter. Moving with uniform velocity, it is moving with uniform velocity of 45 kilometer per hour. The time taken by the train to cross a bridge of length 850 meter. In my opinion, this question Even though in our CBC book they have given you in velocity, it is related to relative velocity, but anyhow, you will understand. The time taken by the train to cross a bridge of length 850 meter, 850 meter. Okay, they are asking you time. Time will be distance traveled by velocity. Of distance total is how much? The total train will have to cross now. If I take tip of the engine of the train, okay, it has entered into bridge. The engine will cross 850 meter. The engine will bypass the bridge. Okay, no? But still, different compartments, last guard compartment, it will be on the bridge only, no? The last guard compartment when it is crossing, till that time engine will be crossing how much distance ahead of the bridge? 150 meter, no? The total distance covered will be equal to length of the train plus length of the bridge. So you will have total distance is 150 meter plus 850 meter. This will become beta 1000 meter. This is equal to 1 kilometer. Is it clear to you? Means to cover this much distance, 1 kilometer. Now I want time to cover this distance. So this is 1 kilometer by its velocity. They have given you 45 kilometer, 45 kilometer per hour. Hour you put here, kilometer cancel. So it is 1 by 45 hour. Hour is in numerator now. And answer is in second. So hour you convert 60 into 60 second by 45. 4 times, 3 times, 3. It will be 20. It will become equal to 80 second. Check, you have 80 second here. In this particular problem, you have a very simple point to understand. When train has length, bridge also you are taking length. So when you are considering distance covered, you have to consider the length of bridge plus length of train. Both you will have to add. Is it clear to you? And then it is simple. Time equal to distance covered by, okay, no, velocity. Now, let us move to next question. A person travels along a straight road for the first half time with a velocity v1 and next half time with velocity v2. The mean velocity is, similar problem we have done. You have a person traveling along a straight road, total time taken, let us take t, they are telling you t by 2. It is moving with v1. And next t by 2, it is traveling with v2. Clear to you? Now, they are asking you mean velocity means average velocity. It is equal to net displacement. So here I will take this as S1, this as S2. So this will be equal to S1 plus S2 by T1 plus T2. Now S1 is how much? S1 is V1 T by 2 plus V2 T by 2. This is S2. By T1 T by 2 plus T2 T by 2. Clear to you? How much you are getting? Here you have t by 2 common, v1 plus v2 t by 2, and t by 2 plus t by 2 is t. Your t is cancelled. You are getting v1 plus v2 by 2. Your answer is here v1 plus v2 by 2. They have used symbol v, so you can take it as v. Tell me, understood? If you understood, I know that now all classwork problem I have done, homework problem also. Actually homework, okay, dear students, you will have to do. But I don't know how many problems you will be able to do, how many problems you will not be able to do. So I myself am doing. All classwork and homework, every problem I have done, and I hope all of you understood. Whereas velocity was concerned, one small definition I have left, instantaneous velocity. Velocity at a particular instant. Okay, no? The velocity at a particular instant, if you consider, okay, no? New page. So now, for instantaneous velocity, velocity at a particular instant. What do you mean by instant? Instant does not mean time equal to 0. Okay, no? You cannot consider time to be 0. If time will be 0, then velocity will be displacement by 0. Anything by 0 will become infinite. The instantaneous instantaneous velocity is struck. Now, you want instantaneous velocity, right? Velocity at a particular instant. If you go, actually, we are needing calculus here, limit del t tend to 0, del x by del t. Actually, correctly beta it is, because you are not knowing calculus, so you will not be capable to understand at this time. Velocity at this time, just remember, instantaneous velocity is velocity of a particle at a particular instant. But instant does not mean 0. You have heard about instant coffee. Can you prepare in 0 time? Not possible, na? It will take time, but it will take very, very little time. So when you talk about instantaneous velocity, it is velocity in a very, very short interval of time. How much? It is 0, but not 0. Clear to you? Only for definition purpose we will be keeping. Now, next my physical parameter will be, physical quantity will be acceleration. Acceleration is rate of change of velocity. I will be going for acceleration. It is rate of change of velocity. Simple definition, if a particle have initial velocity vi, v initial, and after time t velocity has changed to v final. You'll tell how velocity will change, sir. You'll exert some force. By exerting force, you can change the velocity. Acceleration is rate of change of velocity. When you talk about change of velocity, always you should subtract initial from final. So your acceleration will be v final minus v initial by time. In the language of calculus, later on I will teach you, this will be equal to dv by dt. This will also be equal to, now just I'm mentioning, I'm not teaching you, because for this I need differentiation. It can also be written as dv, and here I'll put dx, here I'll put dx, I'll put here dt, dx by dt will be velocity, it will be v dv by dx. But these two we will study later on. At this time, acceleration, we will take very simple classical definition, change of velocity divided by time in which this change of velocity has occurred. Velocity and acceleration, it is not essential that they will have same direction. Simple example you take. I'm taking a particle, I'm projecting it vertically up. The velocity is acting in upward direction, and acceleration due to gravity is acting in downward direction. They are acting in opposite directions. Understanding? No. Actually, direction of acceleration will be that in which change of velocity will take place. You will also have uniform acceleration and non-uniform acceleration. If in equal interval of time, change in velocity will be equal, then you will say that body is moving with uniform acceleration. Or simply you say, if magnitude and direction of acceleration factor would not change with time, then body is moving with uniform acceleration. If change of velocity in equal interval of time will be different, then you say that body moves with non-uniform acceleration. Mostly in CBC, concept building course, we will be solving the problems related to uniform acceleration. Because for solving problems related to non-uniform acceleration, you need calculus, you need these formulae, v dv by dx. For dv by dt, velocity, you will be taking dx by dt. So those type of problems will be keeping when you will be coming near us. At this time, we will take just classical concept of acceleration, final velocity minus initial velocity divided by time. And all equations of motions I will be discussing, okay, no, by considering uniform acceleration, we will not consider any problem related to non-uniform acceleration. About acceleration and equations of motion, I'll be teaching you tomorrow. For today, till here I am keeping. Thank you to all of you. Now there may be a break for 10 minutes and then your math class will start. Thank you. Have a nice day.
Good morning, students. So yesterday we have done polynomials. So I have given homework worksheet number 3 for you people. So we'll discuss questions based on it, and then we'll discuss the next topic of today, which is ratio and proportion. All right. So let's discuss the first question. I hope all of you have done the homework. Let's discuss the first question, which is fx equal to x to the power 4 minus 2x cube plus 3x square minus ax plus b is a polynomial such that when it is divided by x minus 1 and x plus 1, the remainder are 5 and 9 respectively. If fx is divided by x minus 2, then remainder is what? Okay. So in this question, what I'll do? Okay, they are saying that it is when divided with x minus 1 and x plus 1, the remainders are 5 and 19 respectively, right? So what is the root of x minus 1? The root of x minus 1 is 1, right? So I'll put 1 in this. So I'll get f of 1 is equal to 1 minus 2 plus 3 minus a plus b. This is given to be how much? They have given this to be how much? 5. Okay. So from here I'll get one equation in a and b, which is 1 minus 2 minus 1. Minus 1 plus 3 is 2. And 2 if it goes that side, I'll get b minus a to be how much? 2. Okay. And similarly, if I put f of minus 1, why? Because this roots it what? Minus 1. So if I put it here, I will be getting 1 plus 2 plus 3 plus a plus b is equal to how much? 19 they have given. So according to this, a plus b will be equal to 19 minus 6, right? Which is how much? 13, right? Which is how much? 13. Now I can say from here that if I add these two, right, I'll get 2b equal to 15, right? And then if I subtract them, I'll be getting 2a equal to 11, right? So a will be equal to 11 by 2 and b will be equal to 15 by 2. Okay, and what are they asking? They are asking what is the value of what is the value of x minus 2 when it is divided with x minus 2. So for x minus 2, what I'll do? I will put the value of x equal to 2 in this, right? So if I put the value, what I'll get? F of 2 is equal to 2 to the power 4 minus 2 into 2 cube, right, plus 3 into 2 square minus a into a is how much? 11 by 2. A is how much? 11 by 2. So I'll take an eraser. A is 11 by 2 into 2 plus b. B is how much? 15 by 2. Understood? So from here I'll get the value. Okay, they have not marked the answer, I guess, but from here I'll get some value. Understood? So this is the how to solve the first question. Okay, then the next question, number of positive integer x for which fx is equal to x cube minus 8x square plus 20x minus 13 is a prime number. Okay, number of positive integer x for which this should be a prime number. Now this is a very interesting question. I think most of the students must have struggled in this question. So how to do this kind of question is, we need to first find one of the root of this equation. Okay, we need to first find one of the root of this equation. How will I find? I will try by hit and trial method. Hit and trial method. What is that? I will start with 1, x equal to 1, right? Then check for minus 1, then 2, then minus 2, so on, till the time I get one at least root of this equation. Okay, so if I put here x equal to 1, right? So what I'll get? F of 1 is equal to what? 1 minus 8 plus 20 minus 13, right? 1 minus 8 plus 20 is minus 13. This is actually equal to what? 0. It means that 1 is the root of this equation. It means that 1 is the root of this equation. If 1 is the root of the equation, can I say that x minus 1 is a factor? X minus 1 is a factor of fx, right? Then to find the other factors, what I'll do? I will divide this fx with x minus 1. Okay, So what I'll do, I will do division here. So we have x cube minus 8x square plus 20x minus 13, and this is how much? X minus 1. All right. So for x cube, if I divide, I will be getting here x square. Okay, and here I'll be getting x cube minus x square, right? Minus and plus, this will cancel. Okay, so you'll get minus 8x square plus x square is how much? Minus 7x square plus 20x minus 13. Now from which I need to multiply? Minus 7x, right? So I'll get minus 7x square, and minus will become plus, to 27x, right? Now I'll subtract this. So if I subtract, how much I'll get? I'll get minus, right? Achha, no, it will be plus 7. Na? This will be how much? Plus 7x. All right. Now if I subtract this and this will cancel. Okay. And 20x minus 7x will be how much? 13x minus 13. Right? 13x minus 13. Now I need to multiply this with 13. Right? And this will become 13x minus 13. So it must be equal to 0. Right? This must be equal to 0 because we have said that x minus 1 is a factor of this fx. Right? So can I say that fx is equal to x minus 1 x square minus 7x plus 13, right? Because to both the factors, if I multiply, I should get fx. Okay. Now they are saying that it has to be a prime number, right? What is the definition of prime number? That one of the factor is the number itself and the other factor is 1, right? So the other factor means either this can be 1 or this can be 1, right? So when x minus 1 equal to 1, right, I'll get x is equal to 2. I'll get x is equal to 2. And when I get x square minus 7x plus 13 equal to 1, so I'll have x square minus 7x plus 12 equal to 0. So from here I'll have x equal to 3 and x equal to 4, right? At x equal to 3 and x equal to 4, both this will be an prime number. Understood? So how many values of x I am getting? 3. All right. So this is a very interesting question. We'll do the next question now. The remainder when the polynomial p of x is divided with x minus 1. Now this is very simple. What I'll do, what is the root of x minus 1? The root of x minus 1 is how much? 1. So I will just plug in the value 1 in this. So if I do that, I will get 1 minus 3 plus 2 plus 1, right? So 1 minus 3 is minus 2. So I will be getting what? 1. This was a simple question. Just plug in the value, and whatever is the value, that is the remainder of px. Then the next question. If x minus a is a factor of x cube minus a square x plus 2, then a is equal to what? Right? So what I'll do, I will put the value a in this. If I put it, I'll get a cube minus a cube plus a plus 2, right? This is what? F of a. And they have given that it is a factor, right? If it is a factor, it means that this is going to give me a 0 value. The remainder should be how much? 0. So this will be 0. And this cancel. So a will be equal to what? Minus 2. Okay, a will be equal to what? Minus 2. Understood? This is the fourth question. Oh, sorry, I think I missed fifth. If x plus y whole square equal to 2 twice of x square plus y square and x minus y plus lambda square is equal to 4, then lambda is greater than 0, then lambda is equal to what? Okay, so let's expand this. Let's see whatever the information is given. We'll expand it and let's see what we get. So we'll get x square plus y square plus 2xy is equal to 2x square plus 2y square, right? If I bring everything on one side, I will get x square minus 2xy plus y square equal to 0, right? So I will get x minus y whole square equal to 0, right? If any number square is 0, right, then that number is actually what? Itself 0. So I can say x minus y equal to 0, right? And if x minus y is equal to 0, I can just write it here 0. So it is written as lambda square equal to 4. So lambda is equal to plus and minus 2. Lambda is equal to what? Plus and minus 2. But what are they asking? They are asking for greater than 0. So lambda will be how much? 2. Understood? Lambda will be how much? 2 in this case. Okay. Sixth question. I hope this thing is clear so far. Sixth question. If 2x cube minus 5x square plus x plus 2 is equal to x minus 2 into ax square minus bx minus 1, then a and b are what? This is a very simple question. What I need to do, actually we need to divide this, right? This cubic with x minus 2. And whatever is the quotient, that will be the quadratic given to us. Okay. So if I write x minus 2 outside and then divide 2x cube minus 5x square plus x plus 2, right? So what I'll do here, I'll multiply with 2x square. So I'll get 2x cube minus 4x square minus plus, right? This will cancel. Now minus 5x square plus 4x square will be how much? Minus of x square plus x plus 2. Correct? Now I need to multiply this with what? Minus of x. So I'll get minus x square plus 2x plus minus. Right? This will cancel. So I'll be having how much? Plus 2. And here ultimately I'll be having minus x. Then last I'll get minus 1. Understood? So 2x square minus x minus 1 is actually what? Ax square minus bx minus 1. Okay. So I can compare and say a is 2, right? And b is 1, right? A is 2, and because minus b is equal to minus 1. Understood? Minus b is equal to minus 1. So we can say that this is the right answer. Understood? All right. Next question. If p of x is equal to 2 plus x by 2 plus x square minus x cube by 3, then p of minus 1 equal to what? Again, in this I will just plug in the value minus 1. So I'll get 2 minus half plus 1 minus, or minus is plus 1 by 3. So it will be how much? 3 minus half plus 1 by 3. If I take LCM, I'll be getting 3 into 6, which will be 18 minus 3 plus 2 divided by 6. So 20 minus 3 is how much? 17 by 6. Right? So this is the right answer. Right? 17 by 6 is the right answer. Just plug in the value. Whatever is the value we are getting, that is the value of px at x equal to minus 1. Okay. Now the eighth question. A quadratic polynomial is exactly divisible by x plus 1 and x plus 2 and leaves the remainder 4 after division by x plus 3. Then the polynomial is equal to what? Okay, leaves the remainder 4 after dividing by x plus 3. So if it is a quadratic polynomial, I can write p of x, right, as k times of x plus 1 into x plus 2, right? Because it is exactly divisible by what? X plus 1 and x plus 2. But we don't know what is k. Am I correct? But they have given one more information. It leaves the remainder 4 after division by what? X plus 3, right? So if what is the root of x plus 3? It is x is equal to minus 3. So if I plug in x equal to minus 3, the remainder is 4. So p of minus 3 is equal to k times of minus 3 plus 1 into minus 3 plus 2, which will be k times of minus 2 into minus 1, means 2k. But they have given the remainder is how much? The remainder is how much? 4. So I will say from here that k is equal to 2, right? I'll say from here that k equal to 2. If k is 2, what will be the polynomial? The p of x will be equal to what? 2 times of x plus 1 into x plus 2, correct? 2 times of x plus 1 into x plus 2, which will be how much? 2 times of x square plus 3x plus 2, which means 2x square plus 6x plus 4, right? So which is the polynomial in this case? It is the answer B. All right. Okay. Then the next question. Now this is also one of the interesting question. A lot of students, when I was teaching this in class CBC 1, that time they had this doubt. So we'll discuss this also. It's an important question. I don't know how many of you have got this, but let's see how to solve this kind of question. So what they are saying, let x is equal to 2008 to the power 1004 plus 2008 to the power minus 1004. Then, and y is also subtraction of this. Then the value of x square minus y square is equal to what? Okay, so in this case, you need to know one property of indices. What is that? That x to the power minus a is nothing but 1 upon x to the power a. Right? X to the power minus a is nothing but 1 upon x to the power a. If this is true, right, so what I can say? I can say that 2008 to the power 1004, if I say it to be a number alpha, right? If I say that to be a number what? Alpha. So what is this? This is alpha to the power minus 1, right? This will be what? Alpha to the power minus 1. So I can say that x is equal to alpha plus 1 upon alpha, right? Because alpha to the power minus 1 is what? 1 upon alpha, right? And same logically y will be what? Alpha minus 1 upon alpha, right? Y will be equal to what? Minus 1 upon alpha, right? And what they are saying, we need to square and subtract them. So if I square this, what will I get? Alpha square plus 2 plus 1 upon alpha square, right? And y square will be how much? Alpha square minus 2 plus 1 upon alpha square. On subtraction, what will happen? Right? This will cancel, this will cancel. So, can I say that x square minus y square is equal to what? 4. X square minus y square is equal to what? 4. There is the answer. Understood? Let's do the 10th question. In 10th one, again the same property will be used. In just as previous slide, I have explained that that x to the power minus a is nothing but 1 upon x to the power a, right? So if I simplify this, what will I get? I will get it is written as 1 upon x cube minus 1 upon y cube upon 1 upon x cube into 1 upon y plus 1 upon x square y square plus 1 upon y cube into x, right? The simplified version is this. Okay, now if I just cross multiply numerator and denominator and take LCM in denominator, right? So what will I get? I will get it to be, I'll get okay, I will get y cube minus x cube, right, upon x cube minus, upon x cube into y cube upon x cube into y cube. Then here what will I take the LCM? LCM will be how much? X cube and y cube, right? X cube and y cube. So I will get y square, right, plus xy, right, plus x square upon x cube into y cube, right? X cube into y cube. So both the denominator will be cancelled, right? So this will be simplified into what? This will be simplified into y cube minus x cube upon y square plus xy plus x square, right? Now here we have to remember the formula of a cube minus b cube. What? A cube minus b cube. And the formula is what? A minus b into a square plus ab plus b square, right? So from there I can say y cube minus x cube, right, will be equal to what? Y minus x into y square plus xy plus x square divided by y square plus xy plus x square, right? Now I can just remove this, so I'll have y minus x, right? So y minus x is option B, Okay, so this is the 10th question. Next, what are they saying? A cubic polynomial p of x is such that p of 1 equal to 1, p of 2 equal to 2, and p of 3 equal to 3, and p of 4 is given to be 5. Okay, then the value of p of 6 is equal to what? Now this is a very interesting question. Okay, just like I told that the quadratic will be of the type k into x plus 1, k into x plus 2. Similarly here the cubic polynomial will be of the type k times of x minus 1, x minus 2, x minus 3 plus x, right? Plus x. Why? Because see, when I plug in the value of x equal to 1, right, this thing will become 0 because x minus 1 is a factor. So directly I'll get remainder as what? 1. If I put 2, I will get the remainder as 2. If I put 3, I'll get remainder as 3. Understood? So now they have given, I need to find the value of this k. For that, they have given that p of 4 is how much? 5. So I will plug in the value of p of 4. So p of 4 is equal to k times of 4 minus 1 is 3, 4 minus 2 is 2, and this is how much? 1 plus 4. Right? This they are giving it to be how much? They have given it to be 5. They have given it to be 5. So I can say 6k plus 4 is equal to 5. So can I say 6k is equal to 1 or k is equal to 1 by 6? Right? Or k is equal to how much? 1 by 6. Okay, if k is 1 by 6, then I can just substitute the value of k here. So what p of x will become? Right? P of x will become x minus 1, x minus 2, x minus 3 divided by 6. Right? Divided by 6, because 1 by 6 is divided by 6 plus x. Now what are they asking? They are asking p of 6. Right? So for p of 6, if I put 6 in this, I'll get 5 into 4 into 3 divided by 6 plus 6. Correct? So 6, this will be going with 2. So I'll be having 10 plus 6, which will be how much? 16. So the correct answer of this is what? A. Understood? The correct answer for this is how much? A. Now, next question. The expression this is simplified to what? Okay, in this also law of indices is used. What is law of indices in this case? You must be knowing that x to the power a to the power b is equal to x to the power b to the power a is equal to x to the power ab. Right? We can just multiply the power. Right? So if it is the case, what I can say? First of all, it's a square of this, right? It's a square of this. So I can say that a to the power 9, right, into what is first? 1/6, right? Then what is the next? 1/3. Then their whole power is how much? Then their whole power is 4. Then their whole power is how much? 4. And then since there are twice of this, so I'll multiply with 2. Correct? So now this is how much? 9 into 4 is 36, and 36 divided by 18 is how much? 2. So a 2 into 2 is how much? A to the power 4. Understood? So the answer is what? D. Okay? So this is how we do solve this question. We just multiply the number and we'll get it. Or you find one of the value, that value will be a square. The other will also be a square. So a square into a square is how much? A to the power 4. Okay, next. 13th. 13th they are saying if 2x plus z equal to 0, then 8x cube plus 27y cube plus z cube divided by x, y, z equal to what? Okay. Can you see that this is the cube of 2x, this is the cube of 3y, and this is the cube of z, right? So I can apply this formula that a cube plus b cube plus c cube is equal to 3abc, right? Is equal to 3abc if a plus b plus c is equal to 0. If A plus B plus C is equal to 0. So in this case, I can say that this will be equal to, this expression will be equal to what? 3 times of 2x into 3y into z, and they are dividing it with what? X, y and z. They are dividing it with what? X, y and z. So what answer I will be getting here? 3x, y, z cancel. So I will be getting 3 into 2 into 3. So that is how much? 18. Right? That will be how much? 18. So this is the answer for 13th question. Then next, one of the factors of the expression x to the power 4 plus 8 is what? Okay. So this is simple. What I will write? I'll write x to the power 4 plus 8x is equal to x into x cube plus 8. Right? So this will be x into x cube plus 2 cube. Now I can again use a formula of a cube plus b cube, and this will become x plus 2 x square plus 2x plus 4. So it has a factor of what? X plus 2. Right? It has a factor of what? X plus 2. Then next, if x is equal to half, then the value of, last question this is, x equal to half, then the value of x plus 1 upon 1 plus 1 by x is what? Okay. So see, this is x plus 1 upon 1 plus 1 upon 1 plus 1 by x. So if x is equal to half, can I say 2 is equal to 1 by x? Right? 2 is equal to 1 by x. So I can just write the value here is what? 2. Right? So this will become what? 1 by 3. Right? So this will become, so there is one more x here. So I can say half plus 1 upon 1 plus 1 by 3. If I take LCM, it will become what? 4 by 3. Hai? So this will be how much? Half plus 1 upon 4 by 3. This 3 will go up. So it will become half plus 3 by 4. Right? Now if I again take LCM, I'll get 2 plus 3 by 4, which is how much? 5 by 4. Right? So this will be answer is at A. Understood? So these are all the questions. Okay. We have given the homework yesterday. Now today we'll be doing ratio and proportion. All right. Ratio and proportion. So we'll start with that. Just ratio and proportion. Okay. So sir, I think sir has given you homework. We'll start with ratio and proportion. Give me a minute. Okay, so we'll start with ratio and proportion. I hope all of you know what is the ratio. Achha, this is a mathematics lecture, so I'll write mathematics. Right? Now, this is what? Ratio and proportion. Ratio and proportion. So first we'll understand what is a ratio, right? Ratio. See, if A and B are two quantity of same kind, right? Of same kind, then A is to B is the ratio of A is, right? Is the ratio of A and B. A is to B is the ratio of what? A and B. And what is it is equivalent to? It is equivalent to A by B. Right? A by B. But A and B both has to be of the same quantity. Right? So this is the definition, a basic definition of what? Ratio. Right? Now in this case, this A is known as antecedent. Right? And B is known as consequent. Right? I don't think it is required to remember, but just for the information purpose, I have written it. A is antecedent, B is what? Consequent. Okay. Then in a ratio, right? If suppose A upon B is given, I can multiply it with any any natural number or any real number, right, the ratio will still remain unchanged. Okay, so m and n can be any number, but if I multiply and divide with both the antecedent and the consequent, that is the numerator and denominator, with the same number, the ratio will remain unchanged. It will be same. A upon b will be equal to ma upon nb and na upon nb, right, where m comma n belongs to, so on, where m comma n belongs to any real number, right, rational, irrational, anything, but it will be what? Ratio will be remaining same, right. Now if they have given that a is to b, right, is greater than c is to d, right, then we need to first check, whenever we are comparing any inequality or equality, we need to first check whether a, b, c, d are all positive numbers. All what? Positive. If they have given like this, so what I can say? I can say a upon b is greater than c upon d. Since all of them are positive, what I can do? I can write it to be equal to AD is greater than BC, right? AD is greater than BC. Now think, if any of them becomes negative or both the ratio are negative, then what will happen? Okay, just think about it. This will be learning when you join the regular classes. That time we'll be learning it. It's not the part of CBC, right? For CBC, I have made all the terms as what? Positive. Then only we'll be cross multiplying the equality in the ratios, right? Same thing is that if A is to B is equal to C is to D, right, is equal to C is to D, then what we can say? That A upon B is equal to C by D, that is AD is equal to BC, that is AD is equal to BC. And the last, if it is for negative, then also it is going to be same, that is A is to B is less than C is to D, then again A by B is less than C by D, or I can say that AD is less than BC, right? AD is less than BC. Understood? I hope this part is clear for the three equalities, right? Now we'll understand about what? Proportion. Okay, next topic is what? Proportion. Okay, I'll take a new slide. Okay, now what is the proportion? When two ratios are equal, when two ratios are equal, right, then what I can say? Then I can say that A by B is equal to C by D, right? That is what? A is to B is equal to C is to D, right? A is to B is equal to C is to D. So for proportion, what we can say? That A is to B is in proportion to C is to D, right? Just whenever the two ratios are equal, we can write it in the terms of proportion. A is to B is raised to C is to D, is in proportion to what? C is to D. So this is all about proportion, all right? So we can compare two ratios with the proportion sign. Understood? This I think you already have done in your 9th and 10th, but just we are revising it, that what is a ratio and what is a proportion. I hope all of you have understood this part. Now we'll go to the next point, which is the properties of ratios, which is the important part, right? Properties of ratios. Okay, now in any, see, if A upon D is equal to B upon C, right? Here, first thing, AC will be equal to BD, right? AC will be equal to BD. So what are A and C? A comma C are known as what? Extremes, right? And B and D are known as what? Means, right? A and D are, A and C are what? Extremes, and B and D are what? Means. So if they are equal, can I say that product of extremes product of extremes is equal to product of means. This is the first property of ratios, right? Product of extreme is equal to product of means. All right, because we know that if AD equal to BC, then I can say that AC will be equal to what? BD, right? From here we get the first property of ratio. AD will be equal to what? Sorry, AC will be equal to what? BD. Then the second property, right? Now second property, if A is to B is equal to C is to D, right? If A is to B is equal to C is to D, right? So what does this imply? This implies that A by B is equal to C by D, right? This is implying that A by B is equal to C by D. Then there is a property known as invertendo, right? Invertendo, right? What do we do in invertendo? That B upon, the name itself is saying B upon A will be equal to what? D upon C. B upon A will be equal to what? D upon C. We can just reciprocal both the ratios and that they will be equal. This property is known as what? Invertendo. Okay, I hope this is clear. This is the first property of ratio, invertendo. You don't have to actually remember the name of all of them, but you have to remember the property at least. Okay, the last two, for them you have to remember the name. Okay, it is componendo and dividendo because it will be used in many questions and it will be referred in many questions, right? So that is why you have to remember their name. Okay, then next is what? Again, if A by B is equal to C by D, right? Again, A by B is equal to C by D, then what I can do? I can exchange the means, right? Then I can say that A by C is equal to B by D. Okay, this property is known as alternando. This property is known as what? Alternando. Okay, alternando. Then next, which property? I think second one it is. No, it is the third one. Right. Then the next, fourth one, right? What is fourth one? That if A upon B is equal to C upon D, right? If A upon B is equal to C upon D, then what I can do? I can write A plus B upon B is equal to C plus D upon D, right? A plus B upon B is equal to what? C plus D upon D, right? This property is known as componendo, right? Componendo. This is something what you have to remember, that you can add both the numerator and denominator in numerator or denominator, but apply on both the side the same thing. Both the side the same thing. For example of this is what? One example of this is, let's say we know that 2 by 3 is equal to 4 by 6. Right? 2 by 3 is equal to 4 by 6. Then by applying componendo and dividendo, what should I get? 2 plus 3 by 3 will be equal to 4 plus 6 by 6, right? 2 plus 3 by 3 is equal to 4 plus 6 by 6, and this is actually true because 5 by 3 is what? 10 by 6. So here we applied componendo. We applied what? Componendo, but still the ratio didn't change. The ratio remains the same. Both the side, the ratio remains the same. So that is why we have to remember this property componendo, right? Just like componendo, there is one more property, right? There is one more property, fifth, dividendo, right? Dividendo. What does it say? If A upon B is equal to C upon D, right? Then I can say that A minus B upon B is equal to C minus D upon D, right? A upon B minus B is equal to C minus D upon D. For this also I can show you an example. Example 4 by 3. We know that 4 by 3 is equal to what? 8 by 6. Right? So if I apply dividendo, I'll get 4 minus 3 by 3 is equal to 8 minus 6 by 6, which is 1 by 3 is actually equal to 2 by 6. Right? 1 by 3 is actually equal to what? 2 by 6. So this is also valid, right? So this is dividendo, that A upon B is equal to C upon D, then A minus B upon B will be equal to C minus D by D. Now there is a combination of both C and D, that is componendo and dividendo, and this is the sixth one. Sixth one is what? Componendo and dividendo. Right, and we say it to be what? C and D. Right, whenever we refer to it in short, we refer it to be what? C and D. What is actually C and D property? That if A upon B is equal to C upon D, then we can say that A plus B upon A minus B is equal to C plus D upon C minus D. Right, A plus B upon A minus B is equal to C plus D upon C minus D. For example, for this again, I am taking the same ratio, 4 by 3, right, is equal to what? 8 by 6. 4 by 3 is equal to what? 8 by 6. So applying C and D. Applying C and D, right, what will I get? I'll get 4 plus 3 by upon 4 minus 3 should be equal to 8 plus 6 upon 8 minus 6. Right? What is 4 plus 3? 7. 7 upon 1 should be equal to 14 upon 2. And this ratio is correct. That's why we can say that C and D property holds in this. Right? So when A upon B is equal to C upon D, then A plus B upon A minus B is equal to C plus D upon C minus D. This is a very important property. So I will request all of you to remember this property. Right, componendo and dividendo. Okay, this is the last one, last property of ratio and proportion. So remember componendo and dividendo. Invertendo and alternando is not that much important. So please at least remember componendo and dividendo. Okay, and the name in short we say it to be what? C and D. Okay. Okay, now let's do some examples on this. Right, let's do some examples on this. What kind of examples are there? Let's see. First example is if 2x plus 7y, right, is to 4x minus 3y, right, is in proportion to 8 is to 3, is in proportion to 8 is to 3, then find the value of x is to y. Then find the value of x is to y. So in this case, we'll apply the properties of C and D. Okay, how we'll apply? Let's understand. So 2x plus 7y upon 4x minus 3y is equal to what? 8 by 3. Actually, in this case, you don't need to apply C and D, right? Because the numbers are different. Okay, so basically what you will do here, just multiply. That is product of extreme is equal to what? Product of means. So if I do that, what I will get? 3 into 2x plus 7y is equal to 8 into 4x minus 3y. Right? So what I'll get from here? 6x plus 21y is equal to 32x minus 24y. Right? 32x minus 24y. So if I send it this side and this side, what will I have? I will have here 21 plus 24 is how much? 21y plus 24y is equal to 32x minus 6x. Right? 32x minus 6x. And what is this equal to? This is equal to what? 45y. Right? 45y is equal to what? 26x. Right? So can I say x by y is equal to what? 45 by 26. Right? X by y will be equal to what? 45 by 26. Understood? Alright, let's do the next question. I hope this is clear to everyone. Just we have applied the simple property that product of extremes is equal to what? Product of means. Okay, let's do the next question. The next one, it is saying if 3a plus 4b upon 3c plus 4d is equal to 3a minus 4b upon 3c minus 4d, then a by b is equal to what? There are 4 options. I will give you a time to solve this. C by d, b, d by c, right? C 1 and d is 0. Try to solve this question, all of you. Okay, we'll discuss this. Okay, so in this one, first thing what I'll do, first I will just exchange the means, right? Because 3a plus 4b and 3a minus 4b are given, so I'll just exchange the means. If I exchange the means, what will I get? 3a plus 4b upon 3a minus 4b will be equal to 3c plus 4d upon 3c minus 4d, right? 3c minus 4d, right? Now this is clearly what? This is what? Componendo and dividendo. Clear case of what? C and D. Understood? After applying alternando, this is a clear case of C and D. And now C and D is applied to what? It is applied to 3a upon 4b is equal to 3c upon 4d, right? Because if I apply C and D to this, I'll get the same ratio, right? So now 3 by 4 cancel, and what I will get? I will get A by B is equal to C by D, right? I will get A by B is equal to C by D. That's what they have asked. So option is what? A. Option is what? A. So this is all the questions on what? Componendo and dividendo. And we have completed ratio and proportion. Now we'll be doing the next topic, which is what? Divisibility and cyclicity. Okay, divisibility and cyclicity. All right, so we'll understand them one by one. Okay, I hope ratio and proportion is clear to all of you. You have revised it. Now we'll be doing what? Divisibility and cyclicity. So, test of divisibility. Test of divisibility. Now we'll start with the first number as 2, right? For 2, what is the test? That the unit digit number, should be even. Should be even, right? In even, what do I mean by even? It has to be 0, 2, 4, 6, and 8, right? It has to be, the unit digit should be what? Even, which is 0, 2, 4, 6, and 8. Then only I'll say the number is divisible by what? 2. Okay, then the next thing for 3, what will be there? The sum of all the digits. Sum of all digits, right, should be divisible by 3, right? Should be divisible by 3. So suppose I want to check whether 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. This number is actually divisible by 3 or not. So what I'll do, I will actually do the sum of all the digits. Okay, this is an example I am taking. So actually what I'll do all the sum. So 1 plus 2 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21, right? So if I add all of the digits, right, I'll get what? 21. Now 21 is divisible by 3, it means this number is also divisible by 3. Understood? So what I'll do, I will just add sum of all the digits should be divisible by what? 3. Then only we'll say the number is divisible by 3. Okay, then the next 4. For 4, the number 4, the last 2 digit of the given number, the last 2 digit of the given number should be divisible by 4, right? Last 2 digits of the given number should be divisible by about 4. For example, suppose I like this 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. Okay, and I need to check whether this number is divisible by 4 or not. So what I'll do, I just need to check whether the last 2 digit, which is 92 in this case, if it's divisible by 4 or not. So actually 92 is divisible by 4. That's why this whole number will be divisible by what? 4. Understood? This is the divisibility test of 4. So we have seen of 2, we have seen of 3, we have seen of 4. Now let's go to 5. Now for 5. For 5, what is the test? That the unit digit, we all know this is very simple. The unit digit is either 5 or 0, right? If the unit digit of any number is either 5 or 0, then we say that the number is what? Divisible by what? 5. Understood? Now 6, what the number? 6. Okay, for 6 what I'll do, the number 6 is actually what? 2 into 3. So any number which is divisible by both 2 and 3, both 2 and 3 will be divisible by what? 6. So the number should be divisible by both 2 and 3. The number should be both divisible by 2 and 3. Now there is for 7, actually there is no test. Okay, there is no test for 7. There is a rule, but it is not so important. That's why we will not do for anything for 7. Okay, now we'll again come for 8. For 8, the last 3 digits, should be divisible by 8. Okay, just like 4. For 4, what is their condition? That the last 2 digit is divisible by 4. For 8, we need to check how many? The last 3 digits. Okay, I hope it is clear for 8 also. Then for 9, right? What is the condition for 9? That the sum of, just like 3, the sum of digits, right? So sum of digits should be divisible by what? 9, right? For 9, what do you need to check? The sum of the digits should be divisible by what? 9. So for example, if I want to check for 1, 2, 3, 4, 5, 6, 7, 8, 9, whether this number is divisible by 9 or not, right? So just check it. I'll give you a few minutes to check whether 1, 2, 3, 4, 5, 6, 7, 8, 9 is divisible by 9 or not. To check, what you will do, you will add all the digits, right? Add all the digits and check what is their sum. If their sum is divisible by 9, then we'll say this number is divisible by 9. So 1 plus 2 plus 3, you can actually add them, or you can say that it is a sum of 9 natural number. So the formula is what? 9 into 10 by 2, which is how much? 45, right? And 45 is actually divisible by what? 9. Okay, so I will say that this number 1, 2, 3, 4, 5, 6, 7, 8, 9 will be divisible by what? 9. Understood? Okay, Then we'll go for 10. 10 is very simple. What is the logic for 10? The last digit should be 0, right? The last digit should be what? 0. Then last, I think the divisibility test for last is 11. Okay. After that, I don't think we need it, right? So 11. For 11, what is that? The sum, the difference of the sum of even digit numbers and odd digit numbers should be either 11 or should be either 0 or divisible by 11, or divisible by what? 11. Should be either 0 or divisible by what? 11. So what is the actually I'm trying to say? Suppose I want to check for number 1331. We all know 1331 is actually what? Cube root of 11, right? So how I will check whether it is divisible by 11 or not? If suppose I don't know it's a cube of 11, what I'll do? This is an odd digit. This is an odd digit, right? So I will add the odd digit numbers, right? And also I will add the even digit numbers, right? I'll add the odd digit number and I'll also add the even digit number. If there's a difference 1 plus 3 minus 1 plus 3, if it is either 0 or divisible by 11, then we'll say that the number is what? Divisible by 11. Then we'll say the number is what? Divisible by 11. So for example, if I write 1, 2, 3 and 3, 2, 1, right? this number, whether this number is divisible by 11 or not. So what I'll do? I will check. So 1 plus 3 plus 2 minus 2 plus 3 plus 1. Right? This number will also be divisible by what? 11. Because 1 plus 3 plus 2 minus 2 plus 3 plus 1 will be again 0. So that's why this number will be divisible by what? 11. Am I clear? Okay. So these are the divisibility tests from the number 2 to 11. These are very useful in solving many questions. So please remember them. All the tests. I think all of this is clear for now. And I have given the examples also. Now we'll be doing the last topic for number system, which is cyclicity. Which is what? Cyclicity. So we'll understand what is cyclicity of a number, right? So we'll go to that last topic. I hope this is clear for now. Right? Now what does cyclicity means? First of all, let's understand what does cyclicity means. So see, we all know what is 2 to the power 1, 2. 2 to the power 2, okay, I'll write it here. 2 to the power 2 is what? 4. 2 to the power 3 is what? 8. 2 to the power 4 is what? 16, right? Now, what is 2 to the power 5? 32, right? 2 to the power 6 is how much? 64. 2 to the power 7 is how much? 128. 2 to the power 8 is how much? 256, right? Then 2 to the power 9 is how much? 512. Then 2 to the power 10 is how much? 512, 1024, right? 2 to the power 11 will be how much? 2048. And 2 to the power 12 will be how much? 4096. Okay, I think it's enough to understand what does cyclicity means. So see, there is no exact definition of cyclicity, but this is okay for understanding purpose, that the minimum power of a number after which the unit digits will start repeating. The minimum power of the number after which the unit digit starts repeating is actually what? Cyclicity of that number. Okay. So see, in the case of 2, right? In the case of the number 2, okay, its unit digit is repeating after every fourth power, right? It's in the case of 2, it is repeating after every fourth power. You can see 2 to the power 1 is 2, then 2 to the power 5. The difference between 5 and 1 is what? 4. So again 9 and 5 is also what? 4. So that's why we say the cyclicity of 2, right? Cyclicity of 2 of 2 is actually how much? 4. After every fourth power, the unit digit will start repeating itself. Okay, and for 2, the result is what? I can say in general, 2 to the power 4k plus 1, right? 4k plus 1 will have 2 at the unit digit, right? 2 to the power 4k plus 1 will have 2 at the unit digit. What is 4k plus 1 number? Numbers which when divided with 4 gives remainder 1. Number which when divided with 4 gives remainder as 1. Just like 9, 5 and 1. All these are what kind of number? 4k plus 1. So they will always have 2 at the unit place. Okay. Then for 2 to the power 4k plus 2. 2 to the power 4k plus 2 will always have 4 at the unit place. Right. Then next 2 to the power 4k plus 3. This will have how much? You can see 8. Right. Here it was 4. And last 2 to the power 4k. 4 multiple will always have what? 6 at the unit place. Right. Again, if the next number will be having 2, then 4, then 8 and 6. So this is the what? Cyclicity of number 2. Okay. Similarly, we'll see cyclicity of 3 also and the other numbers also. So I'll go to the next point for 3. Right. For 3 also, if I see 3 to the power 1 is how much? 3. 3 to the power 2 is how much? 9. 3 to the power 3 is how much? 27. And 3 to the power 4 is how much? 81. Then again, if I see 3 to the power 5 will be 243. Then 3 to the power 6 will be 729. And so on, it will repeat. Right. Again, if you can see, the unit digit is repeating after every fourth power. Right. So we can say here cyclicity. Cyclicity of 3 is also what? 4. Right. Cyclicity of 3 is also what? 4. Okay. And just like 2, we will have a result of 3 also. So for 3, what will be the result? 3 to the power 4k plus 1 will be giving me 3 at the unit place. Right. 3 to the power 4k plus 2 will be giving me 9 at the unit place. Right. And 3 to the power 4k plus 3 will be giving 7 at the unit place. And 3 to the power 4k, just 4k. 4k will be giving me 1 at the unit place. Understood? 3 to the power 4k plus 1, 3 to the power 4k plus 2, 4k plus 3 and 4k. And the cyclicity of 3 is also how much? 4. Okay. Then we'll see cyclicity of 4. So 4 to the power 1 is how much? 4. 4 to the power 2 is how much? 6. Then again 4 to the power 6 is how much? 64. And 4 to the power 4 is how much? 256. So here we can see that after every second power, right, the unit digit is starting repeating. So I can say from here cyclicity of 4. Cyclicity of 4 will be how much? 2. Right. And 4 to the power 2k plus 1 will be giving me 4. And 4 to the power 2k will be giving me what? 6 at the unit place. Right. 4 to the power 2k will be giving me what? 6 at the unit place. Then for 5, right? 5 to anyway we know that 5 to the power anything, right, will give me what? 5. So cyclicity of 5 is how much? Cyclicity of 5 will be how much? 1, right? Because after every 1 power only, the unit digit will start repeating. So cyclicity of 5 will be how much? 1. Okay, next. Next, if I see for 6, right? For 6, if I see 6 to the power 1 is how much? 6. 6 to the power 2 is also how much? 36. 6 to the power 3 will be how much? 216. So again, we can see at every place, just like 5, we are always getting what? 6. Understood? So we'll have, so we can say the cyclicity of 6 is how much? 1. After every 1 power, it is repeating itself, right? For 6 also it is how much? 1. Then for 7, right? For 7, 7 to the power 1 is how much? 7. 7 to the power 2 is how much? 49, right? 7 to the power 3 is how much? I think 343, right? And 7 to the power 4, for that I'll just multiply this with 3. So I'll get getting 1 at the unit place, right? I'll be getting what? 1 at the unit place. So I can say cyclicity, and after 1, if I again multiply, I'll get 7, right? So 7 to the power 4k plus 1 will always have 7 at the unit place. 7 to the power 4k plus 2 will always have 9 at the unit place. 7 to the power 4k plus 3 will have 3 at the unit place. And 7 to the power 4k, right? 7 to the power 4k will have 1 at the unit place, right? So can I say from here also that cyclicity of 7 is how much? 4. Just like 2 and 3, cyclicity of 7 is also how much? 4. Then last, there is 8 also, 8, 9 and 0. So for 8, right? 8 to the power 1 is how much? 8. 8 to the power 2 is how much? 64, right? 8 to the power 3. 8 to the power 3 will be how much? 5 and 2, right? 5 and 2. And 8 to the power 4 will be how much? 20. 8 to the power 3. I think it is 2, okay. It is 4096, right? 4096. Then again, after this, if I multiply 8 with this, I'll be getting 8 again at the unit place, right? So I can say that 8 to the power 4k plus 1 will have 8, right? 8 to the power 4k plus 2 will have 4 at the unit place. 8 to the power 4k plus 3 will have 2 at the unit place. And 8 to the power 4k will have 6 at the unit place. Understood? And by the logic, cyclicity of 8 is how much? 4. Just like 2, 3 and 7, cyclicity of 8 is also how much? 4. Okay, then next 9. 9 to the power 1 is how much? 9. 9 to the power 2 is how much? 81, right? And 9 to the power 3 is how much? 729. So it started repeating. So we can say that cyclicity of 9 is how much? 2, right? Cyclicity of 9 is how much? 2. So 9 to the power 2k plus 1 will have 9 at the unit place, and 9 to the power 2k will have 1 at the unit place, right? And to the power 2k will have 1 at the unit place, okay? And last 0. So basically 0 doesn't have any cyclicity, but any number ending with 0 will always have 0 at its unit place, right? Like any power will be what? 0. So for 0, there is only, it will be 0 only at the unit place. So cyclicity is going to be what? 1, right? So like 10 to the power anything will always have 0 at the unit place. That's why cyclicity of 0 will be also how much? 1. Okay. So to summarize, the cyclicity of all the numbers, right? Right, cyclicity of all the numbers, I will divide into 3 categories, right? So 2, 3, 7 and 8, we saw the cyclicity was how much? 4, right? For 5 and 0, right? and also 1, है ना? 5, 0 and 1 and also 6, right? 5, 0 and 1 and 6, it has 1 as the cyclicity. Means any power of these numbers will always have the same number at the unit place. Okay, and last for 4 and 9, right? The cyclicity was how much? 2. So this is the cyclicity table, right? Cyclicity table. Okay, with the help of this we can find out what is the unit digit of any number, right? Of any power. Okay, with the help of this we can find it out, right? So we'll do an example for this. See, if I want to check whether let's say what will be the unit digit at 3 to the power 67. Okay, what will be the unit digit at 3 to the power 67? Right, so what I'll do, I need to check whether 67 is what kind of number, because cyclicity of 3 is how much? 4, right? Cyclicity of 3 is how much? 4. So 3 is what kind of number? 67 is what kind of number, right? So 67 is what kind of number on dividing by 4? It will give me remainder as how much? It will give me remainder as 3, right? So I can say this is of what type? 4k plus 3, right? It will be of what type? 4k plus 3. And any number 3 to the power 4k plus 3 will be giving me what at the unit place? 7, right? We have seen it here, right? 4k plus 3 will give me what? 7. So the unit digit will always be what? Of 3 to the power 67 is how much? 7. So in this case, in this way, I can find out the unit digit of any number to any power. Okay, this will help in finding divisibility also, and this also. Okay, so with this we have completed the number system. Okay, for today the homework I will give you. Okay, homework from your worksheet. Okay, from your worksheet. I think day 5 it is now. 4. Yes. So for today, worksheet number 4, right? Worksheet number 4 is homework, right? Page number it is 61. Okay, page number 61. I think total number of questions are 15. All 15 questions. All 15 questions. Right, all 15 questions we will discuss, and then I think after that the number system is almost over, right? Everything is over in that. Few 1 or 2 questions if you are getting stuck, we'll discuss it tomorrow. Okay, from the book only, page number 61. All 15 questions are homework, and we'll practice questions also tomorrow. And I think we'll start quadratic equation if we have time tomorrow. Otherwise, we'll start on Monday. Okay, so. This is all about it. We'll just revise the lecture, whatever we have done today, and then we'll end it. Okay. So homework I have already written on the screen. Homework is worksheet number 4, right? Page number 61. All 15 questions. Okay. So what have we done today? Today we solved all the questions from yesterday, and we have learned about ratio and proportion. Right, so what is ratio and proportion? If A and B are 2 quantities of same kind, then A is to B is equal to what? A by B. In this, A is known as antecedent and B is known as consequent, right? And A by B is equal to M upon A, MA upon MB, right? NA upon NB. It means if we multiply numerator and denominator with the same number, the ratio will not change. Then we have seen the inequality. Right, inequality in ratios, we can cross multiply only and only when the numbers are what? Positive. If the numbers are not positive, then what we have to do? We don't know right now, but we will not be multiplying, cross multiplying, right? Just normal multiplication. Then this was we have done. Then we have seen what is proportion. So if 2 ratios are equal, we'll say that they are in proportion to each other. And how do we read it? We read it as A is to B is to C is to A is to B is proportion to C is to D. Okay. Then we have we have understood that these two are known as extremes and these two are known as means, right? And what is the first property of ratio? That product of extremes is equal to product of means. Okay. Then the next property we have learned is about invertendo. Invertendo is that we can reciprocal both the ratios and the ratio will not change, right? Both the ratio will be still equal. Okay. Then we can exchange the means, right? And still the ratio will be equal. So it is what? Alternando. Okay. Then something we new learned is componendo. Componendo is what? That if A upon B is equal to C upon D, then A plus B by B is equal to C plus D by D. Okay. This is an example for that componendo. Then dividendo. What is dividendo? That A upon B is equal to C upon D, then A minus B by B is equal to C minus D by D. This is an example of dividendo. Okay. Then both combine componendo and dividendo. What is combined componendo and dividendo? That A plus B upon A minus B is equal to C plus D upon C minus D. Right. This is componendo and dividendo. We also, in short, we'll say C and D. Then we have seen few questions. Okay, on this. Then we have seen divisibility, right? For 2, the divisibility test is what? That the unit digit should be a even number 0, 2, 4, 6 and 8, right? For 3, the sum of all the digits should be divisible by what? 3. Then for 4, the last 2 digits of the given number should be divisible by what? 4. Okay, then next 5, the unit digit should be either 5 or 0. For 6, the number should be divisible by both 2 and 3. For 7, there is no divisibility test, right? For 8, the last digit should be divisible by 8. Okay. 9, the sum of digits should be divisible by 9. Just like for 3 we saw. And for 10, we already know the last digit should be what? 0. Then for 11, the difference of the sum of even digits and the numbers at odd digits should be what? Either 0 or divisible by 11. We saw 2 examples, 1, 3, 3, 1 and 1, 2, 3, 3, 2, 1, right? So these both numbers were divisible by 11. Then we saw cyclicity, right? What is cyclicity and what is the cyclicity of all the numbers? So the result of this is what? This table. Cyclicity 2, 3, 7, 8 is how much? 4. It means that after every 4th power of these numbers, the unit digit will start repeating itself. Then for 4 and 9 it is 2, and for 5, 0, 1 and 6 it is how much? 1. Okay, and this is today's homework, okay, which we'll be discussing tomorrow. Okay, alright, thank you everyone, see you tomorrow.